Welcome to qnawire.
Okay, let's go ahead and solve this problem. We are given f equals to x squared comma y squared comma z squared. The region S is quite complicated. Z is between 0 to square root of 1 minus y squared, which is described as a half a cylinder, okay, which is described down in the picture that I've drawn. X is between 0 to 2, so that's a plane from x equals to 0, and the other plane x equals to 2. So you will get this pipe shape that's cut in half, okay? As usual, we're going to find f dot n, the normal vector times f, and then we're going to try to evaluate the double integral through that. So there are going to be four surfaces. One that's heading backwards, one that's coming towards us, one that's going to the left, and the last part that is going to be the curvy portion. I made it look like it was going towards the right. Okay, so let's work on them one by one. The reason why I labeled the first one I1 is because it was the easiest to find. The normal vector is just a plane x equals to 0, so it's 1 comma 0 comma 0. And then we know that f dot n is equal to x squared. But we also know that x equals to 0, so this is 0. Hence, the flux right there is 0. So that one is straightforward. I2, n, very similar. It is equal to 1. Oh, should that be a negative 1? Hold on, let me double check. Sorry, yes, that should be a negative 1. So that's a negative x squared because it's heading towards the backwards, okay? Now, x to the positive direction, that's 1 comma 0 comma 0. Okay. Either way, similarly, we can calculate what f dot n is. Now, this is positive x squared. And here we know that x is equal to 2, so x squared is 4. Now, to calculate the value of the flux right here, we simply use the fact that what we're trying to calculate is the flux of 4 through the region S, but factoring out a 4, we know that this is equivalent to the double integral with respect to the area of the projection. So we know that this is half a circle, a semicircle, with radius 1, so that'll be pi over 2. So pi over 2 times 4 is 2 pi, so the flux of I2 would be 2 pi. Now I3, let's do it over here because I know that the result is simple. The normal vector is equal to, it's z on the opposite direction, so it will be 0, 0, negative 1. F dot n is going to be negative z squared, but we know that z is equal to 0, so we don't have to worry about that flux. And finally, I4. All right, this is a curvy region, so we have to be very careful. Now, I know that it's a part of a cylinder, so the cylindrical coordinate system works very well here. By choice, I will say that the parameterization of the cylinder or the surface at that point, it is with respect to x and theta, because x is just a straight plane. That's the reason I chose x to be the straight line. It'll simply be x comma, I chose cosine sine, right? Yeah, sine cosine. It shouldn't matter, but I already did the work like this, so I want to be consistent. So r, the partial derivative with respect to x, it'll be 1 comma 0 comma 0. Similarly, with respect to theta, it'll be 0 cosine negative sine. The cross product, in other words, the normal vector, will end up being 0 sine negative cosine. F looks a little bit ugly. It is x squared, y squared is sine squared, z squared will be cosine squared. So when we calculate f dot n, the dot product will be sine cubed minus cosine cubed. Now, when we find the integration of this thing, there are many approaches that you could take, so it is up to how you would like to do it. But one way, a straightforward way, is to say sine squared is 1 minus cosine squared, or cosine squared is 1 minus sine squared. Substitute those in, and then work out the integration using mu substitution. I tried to see if there were any other easy ways to do this. I ended up doing sine theta minus cosine theta. If you factor this out, we know that this is a difference of cubes, so it's sine squared plus sine theta cosine theta plus cosine squared. And then we know that sine squared plus cosine squared is equal to 1, so it simplifies a little bit, but it gave me the exact same result as just substituting sine squared with 1 minus cosine squared and cosine squared with 1 minus sine squared. So either way, you can still do the same calculation to get the same result. So let me put this over here. Oops. There you go. Let's finish up the last work. So we want to evaluate the integration. This is a half circle, a semicircle. So we want to evaluate the angle from 0 to pi, not 2 pi, okay? The radius, not the radius, the value of x is from 0 to 2. And then we have the sine cubed minus cosine cubed, dx d theta. Okay, as I mentioned, if you use u substitution after simplifying this a little bit, you should be able to get 8/3. I'll let you do the calculation on your own. Okay, so let's summarize it. We've figured out that the flux is 0. For I1, for I2 is equal to 2 pi. I3 is equal to 0. And I4 is 8/3. So the total flux is equal to 2 pi plus 8/3. And this is how you do these kind of problems.